There are in principle two ways to prepare a solution in the laboratory with a particular molar concentration. One of them is if the solid is solid, you can simply weigh out the mass that you require for a given concentration and a particular volume. A second way to do this is to actually use something that is called a stock solution, which are pretty common in laboratories. Okay, so stock solution are big badges of a solution with a known molar concentration. So for example, in this case, suppose that we have a concentration of sodium hydroxide of 1 molar concentration. Right? You will have a lot of volume of this solution, and the idea is that you can in principle use this solution already formed to make specific solutions with less concentration than this, according to whatever you're interested in. Okay? The way that you would do this is you would take a known amount, okay, that you can calculate of this stock solution with a pipette. Okay, so this will be an accurate measure. And again, suppose that you need this particular volume, you can measure that out, okay, with the pipette, and then you would take this to a volumetric flask, okay, and then dilute it with water until the volume that you want. And again, depending on how much volume of this stock solution you get, you will get a particular concentration in that volumetric flask, which is your target. Okay, so the question is, how do the calculations work out for this type of dilution problems? Okay, again, this is called a dilution. You take stock solution that is concentrated, and then that adds sufficient water in order to make a more dilute concentration of a specific molar concentration that you want. All right, so the way to work these problems out is to recognize that the number of moles of the solute that you have in this specific volume that you're pipetting out from the stock solution is exactly the same as the number of moles that you have right here, because the only thing that you do from here to there is to actually add water. Okay, so you're not adding the number of moles of the solute, you simply are changing the volume of the solution. And because the molar concentration depends on the volume of the solution, if you're not changing the number of moles of solute, then the molar concentration has to go down. Okay, so in practice, what this means is that the number of moles of your substance X, okay, here, in this volume, in this stock solution that you're pipetting out, okay, has to be identical to the number of moles of your solute in the final target solution that you're interested in. Okay, again, this number of moles doesn't change. The only thing that you're doing is adding water. After you add this volume right there, you just fill up water until the mark. Okay. Now notice that these are solutions. Okay, water solutions. Okay, so a way to actually express the number of moles would be to use the definition of molar concentration. Right, the number of moles or the molar concentration is equal to the number of moles over the volume of the solution. Okay, here we actually know the molar concentration. Okay, of this stock solution, which happens to be this number. Okay, and then the idea would be to take a particular volume with this pipette, and this is what we normally have to determine. Okay, to get a specific number of moles. Okay, so taking this definition, we can solve for the number of moles, and that is simply going to be the concentration, molar concentration times the volume. Okay, we come here and take that. Well, the molar concentration of the initial solution, that is my stock solution, multiplied by the volume that I pipette out of the stock solution is going to be equal to the molar concentration in the second solution, my target solution. This is what I want, okay, multiplied by the volume of this volumetric flask. Okay, when these things are known, usually the target is to know how much volume do I have to take from the stock solution and then dilute it with water until I get the solution that I'm interested in. Right, so then let's actually do a numerical problem to illustrate how this works. Okay, so suppose that my target solution is going to be a molar concentration of sodium hydroxide of 0.0437 molar. This looks like a pretty exotic number, but again, that might be because you want to carry out a reaction in solution with exactly that concentration, and you need exactly that concentration in order to perform the experiment correctly. Okay, and we want the volume that we want right here is going to be 250 milliliters. Okay, so this volumetric flask is going to have a volume of 250 milliliters. And we're going to use this stock solution, which is 1 molar of sodium hydroxide. The question is, well, how much volume of the sodium hydroxide do I have to pipette out and then put it into this volumetric flask and then add water until 250 milliliters. Okay, so this is what we have to use. The number of moles that I'm going to be taking out from the stock solution is going to be equal to the number of moles that I'm going to have at the end in that volumetric flask, and the number of moles is coded by the molar concentration of the volume. Okay, so again, notice that my initial concentration, that is the stock solution, is 1 molar. The volume is what I'm solving for. I need to know exactly how much volume do I have to pipette out. Okay. The target molar concentration is what the problem statement is telling me, 0.0437 molar. And then the final volume, the volume of my final solution, happens to be 250 mils. Okay, so I can do 0.250 liters. Okay, from here you simply can solve for the initial volume. And this number is going to be 0.010.9 liters, which is the same thing as 10.9 milliliters. Okay, so to prepare a solution, 250 milliliters of 0.0437 molar sodium hydroxide from a 1 molar stock solution of sodium hydroxide, you need to pipette out 10.9 milliliters, okay, exactly, pour them into the volumetric flask, and then add enough water until you get to 250 milliliters. Okay, so in this video we have explained what a dilution is and how to actually do a numerical calculation with that concept.